Hello Eastview Scholars, and welcome to another edition of Sharp Shorts. This time we're going to talk about dilutions. In our last video we talked about solutions and how to calculate their concentration through molarity. This is looking at, alright, I already have a solution. You'll see this often with acids. And it's a very concentrated form that I have, and I want to make it a less concentrated form. In other words, I want the molarity to drop and be less concentrated. How do I do that? Well, the basic formula is M1V1 equals M2V2, meaning the molarity of my initial solution and the volume that I use of that initial solution is equal to the molarity of the new solution and the volume of the new solution. Okay? And how do we arrive at that? Because that's really it. The question here is simply, how much strong stuff do I take out of the jar? And how much water do I add to it to make it weaker? Because that's really what a dilution is. But we love showing derivations of formulas, so here we go. In my amazing drawing here, what you see is we have a jar of bad acid, strong, really bad acid. And when I'm going to dilute something, I'm going to pour, in red here, a little bit into this container. And then all I'm going to do is add water. Well, both of these are going to have a molarity, and we go back to our molarity formula. Molarity is moles per liter. Here's my initial set. This little bit of bad acid that I took out has a certain concentration, whatever it was on the jar. Call it 18 molar, I don't know. And that means it has a certain number of moles in the liters, in the volume that it has. Now think about this. When I added water, now I've got my new solution here. It's got its own molarity, okay, which means it has a certain number of moles in a given amount of volume. But remember, I did not change the moles of acid. I just added water. So really, I have the same number of moles here, although my drawing isn't to scale or beautiful, as I had here. The only thing I did was add water to it, more water to it, to make it less concentrated. So if you remember, we can rearrange this three variable equation to moles, which is the molarity times the volume, and we can arrange this one to the molarity times the volume, and we know that the moles were equal. Well, if those moles are equal, then these portions of the equation, the M1, V1, M2, V2 are equal. Like I said, if these are equal, then the rest of the equations have to be equal. That's where it comes from. Okay? And let's just do this simply by solving a problem. Here we're asking you, how would I prepare? Now, let me go back to the formula here. Okay? M1, V1, M2, V2. In these problems, you're going to get 3 of the 4 variables. The thing to be careful is just look at what goes with what. Okay? Make sure that you're keeping the molarity and the volumes of one solution on one side of the equation with the molarity and volume of the other. In other words, just don't mix up. You know, if it says I have something that is, 18 molar and I have 25 milliliters, keep those two together. But you'll get 3 of the 4, and you just have to plug them in and solve. Now, one of the most common questions, you can solve for any of those variables. It'll be, how do you read the problem? We've looked at those types of things in the past. And one of the most common types of questions is given to you right here, asking you how would you make or how would you prepare that dilution. So know that there are 2 things you have to answer here. I need to know how much of this 18 molar stock solution that I have to take out. And then I'll have to figure out how much water am I going to add to get to my total of 1,500 milliliters in my weaker 2.5 molar solution. Okay? So those are the 2 equations. It still starts with the formula M1 V1. Hey, the pen's working pretty good today. Equals M2 V2. And oftentimes, wherever you want to do it on the side, it might be a good idea just to list out M1, V1, M2, V2, and write out what they are so you plug things into the right area. I always suggest that as a good thing. So what do we know? We know we're starting at 18 molar. We do not know this volume. That's one of our questions. How much strong stuff do I need to take out of the jar and put in a beaker? We do know we want to get it to 2.5 molar. And we do know that our final volume with water is going to be 1,500 milliliters at the end. Okay? In which case, once I've done that, I should be able to come over with my formula and then just put things in where they belong. 18 goes here. V1 is the first thing I'm searching for. 2.5 is M2. My final volume is 1,500 milliliters. Now, the nice thing with this equation is, unlike the molarity equation we did in the last one where we have to be moles and liters, this is molarity, but it can be in milliliters. It doesn't matter. V1 and V2 just have to be the same value. So they either both have to be liters or both have to be milliliters. Shoot, they could both be gallons. It doesn't matter. When I run through the math, and you can do this on your calculator, if you do your algebra right, then V1, pen's getting a little goofy, should come out to be 208. Sorry about that. That's a 208. Let me fix that for you real quick here. Okay, let me erase that mess. Okay, that should say 208 milliliters. So what that tells me is I need to go to my jar of 18 molar stock solution, okay, of sulfuric acid, and with a graduated cylinder get out 208 milliliters of that stuff. But I'm not complete. That's 208 milliliters of my stock, okay, the 18 molar. What I need to calculate is then if I'm going to prepare the dilution, then I have to dilute it with water, okay. And how much water do I add? Well, I want to get to 1,500 milliliters total right here. This is my total, okay. And I'm at 200 milliliters in the beaker with the stock solution. So 1,500 minus 208 is 1,292 milliliters of water, okay. So however you want to word it, you would say in your answer 208 milliliters of stock plus 1,292 milliliters of water, or added with 1,292 milliliters of water. But that's what I would do. I would head into the lab. I would pour out 208 milliliters of 18 molar stock solution in a graduated cylinder, pour it into a beaker, measure out 1,292 milliliters of water in a graduated cylinder, pour that into a beaker, and then I would have my solution and I would label it and we would be done. Okay, there we go. In our next movie, we're going to work with solutions in stoichiometry, everybody's favorite. Until then, Scholaranis.